Most people don't mess up their first drone because they don't care. They mess it up because they didn't have the right tools. And the crazy part is, you don't even notice it until something fails.
Right? Because bad tools don't just slow you down, they create bad builds, and bad builds turn into unreliable systems.
I'm Joshua Hill, and this is the Swarm News, where we break down the SUAS the way it actually works, not the way that it sounds in some boardroom. With me, as always, is my co host.
And I'm Vincent Lewis. And before we get into it, I'd like to say thank you to all those who have liked, subscribed, and then follow us on YouTube and on our podcast. And if you aren't following us and like, we'd ask that you go ahead and hit that like and subscribe button now, and follow us and help us to grow our channel. Before we typically go into the episode, I normally have a little bit of news for those who haven't been here, but this week, because there wasn't a whole lot going on in the SUAS industry between civilian and or military side, we're not going to inundate you guys with some boring stuff you probably don't even care about anyway. So with that being said, we're going to just go ahead and roll into the episode. You got anything, Josh?
No, sounds good, man. So let's roll into it. This is part 7 of our 7-part series. So before anyone even powers on a drone, before your first flight, what should they actually have on their bench to get them ready?
Yeah, before you even pretty much get into even flying or doing anything, you typically need to have a basic amount of tools. Most of the time, most people have either a wrench, a pair of pliers, a screwdriver, all those. Those are going to be some you need. But because of the nature of most of your SUAS, you're going to need some specific tools. First thing is your first precision set of screwdrivers, and you're dealing with very small hardware, so you're going to need tools that can be able to adapt to the little tiny screws that you may be messing with. Standard of tools and not in your normal like US standard sets. You're going to need it in the metric. So we'll kind of go into it, but you need the screwdrivers, small precision screwdrivers, and you also will need your own set of hex drivers between 1.5 millimeter up to about 4 millimeter hex drivers. It'll look like this. Get like a set that typically kind of covers all your stuff in it. And you have your screwdrivers. It has your handle to put the screwdrivers and your sockets or hex drivers in. And it also will have little wrenches in it to be able to turn the nuts or things that you need. But the one that's also helpful is that if you don't see, you actually have wrench drivers that'll actually make it a lot easier. So yeah, and you're dealing with very small hardware, and the wrong bit or wrong tool can strip these screws pretty much immediately.
So this is less about convenience and more about not ruining the build.
Yeah, exactly. Once you strip a screw at this scale, you're not fixing it. You're gonna have to try to get it pretty much pulled out or try to break it off to get it out in some of these things. So you really do need to be working with the right tools for the hardware and systems that you're working with, because you'll need them no matter what. So if you don't fix it, you're drilling or replacing parts that you may have to rebuy or build or get, and that becomes a pain in the ass. So drilling things out ain't what you want to do.
Okay. So I think this next tool is the one that really gets people anxious and nervous, and it's soldering.
Yeah. I mean, to be honest, I think that the manufacturers are starting to realize that that is a fear for a lot of people too, and that typically you don't want to be your first time soldering is when you're building it for the very first time. So companies like Speedy B are putting practice boards
That's smart.
are in your builds so that you can actually practice on whatever it is that you're going to solder first. So in this case, you're using this board like this flight controller. You have something that's similar that you can use to actually help you practice prior to actually doing it. Soldering isn't a hard thing, but it's just like anything else. Practice becomes perfect as you do it, and the more you practice at it, the better it becomes as you do it. Having a good tool, so you can go to Walmart and get a soldering iron and hope that it works, and or you can go to Amazon. Don't be too cheap. Don't try to go spend $10 on a darn soldering iron and expect it to meet what you need. You know, at least spend about $50 because you can use a soldering iron for multi different things. You can fix a lot of stuff in your house. On top of, you can use it for artwork. In some cases, you get the right bits, you can actually do tool, artsy things with it. And I guess the gist of it. But soldering irons can be intimidating at first. You also want to make sure that you have the right solder with it. 60/40 solder is typically the solder that you will find everywhere. There are some specialty solder, but 60/40 literally will do what you need. And 60/40 means 60%. If I'm not mistaken, I'll make sure I put this up on the screen for people. It's been a while, but 60% tin with 40% lead. That's what it kind of is a breakout. So it gives you an idea, the material is able to melt, but at the same time, is able to solidify and make a joint that's stiff enough to maintain on top of the chemical bonding that you need that goes along with it. So again, make sure you got the right soldering iron, the right solder, and most of this would be good. And you really need to take it serious. And your soldering joints are your electrical connections for your power and your signal. And honestly, that is everything when it comes down to building your system. If you do not have a good joint, you're not going to have a good system.
So what happens if somebody like cuts corners, buys cheap in this situation? What are we looking at?
Bad joints cause the situation to where your power doesn't get through, or it can cause resistance and heat to build up or instability in it. And with a bad solder joint can cause you more problems where you're trying to troubleshoot an issue with your motor thinking that it's not working well, when in actuality it was your soldering wasn't good enough to actually make connections. Or which could be even worse is that if you get too much solder on, say, the wrong pads, say you put the power on your flight controller, put too much solder and those two joints connect, as soon as you plug in a battery, you're blowing the system immediately because that solder joint wasn't meant to be a solder joint. So that's one of those problems. Others is if you don't properly solder it right, you could actually make it to where your motors don't work because the joint isn't getting a good connection to the board.
Okay. So this is an issue because they are failing while you're flying and not failing on the bench.
Correct. You're not just failing at the bench. They're going to probably fail in air in some of these cases if you don't do it right.
Okay. So let's talk about something that sounds optional, but it isn't.
Yeah. Smoke stoppers. Man, I wish I had a few of those about 5 or 6 years ago. It'd been so nice. I would have saved a bunch of receivers and a bunch of flight controllers if I had it. But smoke stopper is a electrical circuit that goes between the battery and the connection to your flight controller or your drone.
Okay. So this sounds basically like it's your don't destroy everything device.
Basically, it's not.
It kind of saves you, yeah?
Correct. It's what we call don't let out the magic smoke. So you see magic smoke, yeah, you just screwed something up and that ain't probably gonna come back. I've also seen times where you have magic smoke and you're trying to figure out where the fuck it came from and the system's still working. But 90% of the time, if you got magic smoke popping, yeah, you have just screwed up something and you're probably not recovering. So that's why it calls smoke stopper, because it stops the magic smoke coming out.
So skipping this is like gambling.
Yeah, I mean, honestly, spending the 20, maybe $30 for it is like worth its price in gold. You want a smoke stopper so that you can make sure that when you plug in your battery into the aircraft, it recognizes it first and won't let the power of the current or the power go into this flight controller. Two, they typically can give you audible sound so that you know for sure that something ain't right, so that you don't have to wait, because sometimes you could plug in a battery and it may not pop right away. But as soon as you plug it into, say, the computer, or like you cut the switch on for giving it power for the motors, that might be the point where it actually pops it because it's too much. But typically it's not the after effect, it's the point of when you plug in the battery initially, because that initial amount of surge of power is where it's the biggest problem. For that allows you to save yourself from buying a $8,500, sometimes in the case of a flight controller, $1,000 flight controller, all brand new again, and ESCs. So $20 versus $1,000 at a gamble. Unless you're gambling, man. I know, Josh, you're a gambler, so you have pretty good luck. So you can probably go without it. But I
would not for $20. I'm gonna take the safe bet. But yeah. So you just brought up batteries. Let's go ahead and talk about battery checkers. This seems simple. Why do these matter?
Battery checker gives you the understanding of what is the percentage of batteries cell power and or overall amount of power on your battery itself.
Okay.
What you're using the cell checker to do, or your battery checker to do, is to make sure that you're not under, say you're running a battery and you did a flight and you just came back and you're like, man, I don't know if I got 5 minutes out of that flight or if I got 10. And when you bring the aircraft back, you can look at how much percentage of a battery you have. So if you had started with, say, 99% or 100% of your battery and you brought it back and you were at 70-80% of your battery life, it means you still could probably go about to 60. You don't want to typically go under 50% of your battery. You can, but I try not to fly my batteries under 50%.
Okay. So
You
is this about preventing problems and not reacting to them?
That too is more of preventing you from using a battery that doesn't have enough juice in it, because you can mix up. You get two batteries of the same. So, like, I have two of these batteries, right? And they all look the same. How do you know how much voltage is on it without having the checker? And typically, this is where you plug in your checker into this, and it'll let you know what it is. But you can't always look at a battery and say, "Yeah, this is 100%, and my other one is 50." So you need to literally check your voltage before you plug it into the aircraft, because you can make you lose your aircraft. You could actually, blow the battery. If you blow the battery, that means you may actually lose the battery and lose the aircraft because of it having not enough voltage in it. Also, you want to check the cells, because in this you can see there's 1, 2, 3, 4, 5, 6 cells. One of those cells could be bad, and you could have a 6 cell battery that's only showing 5S, and it still could possibly work. If you don't know it without checking it, you could actually be running into a problem offhand. So
Okay.
that's the importance of like the cell checker and why our battery checker is important.
Okay. So what about side cutters? This feels kind of basic, but like, why do these matter?
A pair of good side cutters is literally to help you with, like I got this. I do Gundam stuff, as you haven't seen in the background. So I have several different ones, but this one I use for basically cutting thicker wire, because sometimes you have frayed ends on your wire and you want to clean it up. You want to keep it as clean as you can. Also, you'll have things like, what you call it, zip ties. Just zip tying things down using a simple side cutter can get into little areas in the places that you're zip tying up to, and be able to clip it without clipping the wire itself. So you don't have to use a knife to try to do it. And this actually works out pretty well for multiple reasons, between clipping up wires, between cutting tape, between cutting zip ties. You can do it for all sorts of different things, even cutting edges of your props. Maybe you got a little fray on it that doesn't make your prop not usable, but you can actually just clip it to make it where it'll actually still be usable and enough to where you can do it on all three of your prop, or all four of your props, not three, but make it work. But that's what the side cutter, or in this case, a pair of nippers, can do.
Okay. So, I mean, messy builds aren't just ugly in this case.
It's more of, they're kind of unpredictable in a way. You can build it in a way where if you do it right and you think it through the process, you can pretty much make it look well.
Okay.
It is only if, whoop, there goes the flight controller box. But you can, like in this case, it's all kind of like wrapped up or whatever, right? But in the same gist of it, I taped up the wires so it looks neat, soldered on my joints to make it look as best I could, and made it to where if you look at it, probably not the best if I've ever done. Right now, I got like my LiDAR off to the side, but in most cases, the neater it is, the easier it is to see things on it. So the better it is to actually fly when you're flying and not get it caught up on stuff. So you want it to be as neat and as pretty as you possibly can. Ugly is not.
Okay. So, what about props and motor mounts? What's the risk here? What are we looking at?
So motor mounts are only, typically used if you're trying to angle your motors or you're needing them off the arms of the motors. Props and prop tools are very important. When you look at it, this is where these sockets come into handy. You can use this to turn your nuts, because it actually helps them to get caught on or to tighten down, because if you have the self-tightening or lock nuts, they'll actually make it to where they don't come off in mid-flight because of vibration. So having stuff like this helps your props to stay on. You want to make sure you pick the right prop. So Some props require screws, two screws to lock it in. Some props just require a prop nut. Just depends on what you have. Some of them even actually have a quick connect. So depending on the motor. So you want to make sure that you have the right stuff in regards to that. And then if you buy your right tool set, you can have all the things you need in the first place. You just need to know it as you build your kit.
Okay. So this is all about consistency.
Correct. And as you get it, this won't be a one-time thing. You can use these tools for multiple different things also.
Okay. So let's move on to another thing that people don't think of as a tool, but I mean, your computer is probably one of your most important tools.
Yes. You need a computer to do your programming and get the aircraft in the air in the first place. You may not, in different builds, your computer could be your ground control station. And in some builds, it's just enough to help get your aircraft tuned. But you need a decent computer, not a gaming laptop. You just need a good computer that can connect and allow you to program your aircraft proper way you need to. If you're using Betaflight, if you're using iNav, that computer is the key to you getting that system set up right.
What do you mean by that?
So in order for your computer to be a support to you, or your drone to be able to work with, you have to have the firmware configured in the right way. The firmware is typically being used through your operating system of your computer. You have to have your right drivers. You need to make sure that you have the right firmware to match what the aircraft's flight controller has. Also, if you have ESCs that are running off a specific firmware, the only way you get to it is through the computer itself. So knowing the right firmware, but having the right computer to be able to read that firmware. Now, granted, a lot of times you need to go out and get like the most built out gaming, like extravagant computer. You just need a basic laptop that actually can work pretty quickly, not something that's just like 10 years old that is got a Pentium 1 processor and is still running like Windows 11. You're not going to be able to do anything. You need something that's at least current up to what you have out right now. Windows 11 would be perfect if you were running the most updated operating system with a little bit of RAM and get a decent sized hard drive will be all you need so you can run these programs, because most of them are also running off of the internet, so they're running from the cloud anyway, so you don't even have to really run them directly from the computer.
So what you're saying is the drone doesn't work because you built it. It works.
Yeah, it works because you configure it.
Gotcha.
Let me make sure I say that again. It works because you configure it.
Okay. So how does all of this tie into what we've been talking about this whole series?
Everything we cover, power, control, RF, payload, it all brings it together to give you an encompassing view of what it takes to make just a small drone. They're not hard. They're not that super difficult, but they can be time consuming and they can be difficult if you don't know what you don't know. And that is a key thing. If you don't know anything about them, it takes some time and research to go into it, just like anything else. Like for me, I don't know anything about golf, but I'm learning more about it. And it's interesting to know, certain things in regards, because I'm thinking my swing is a baseball swing, thinking I can do that. In actuality, there's a right way to do it. So just like anything else that you do, you just need to have the right time. And how we're trying to support people is to give you the understanding, and how these all roll into one is like this information that you may not know that you need tools specifically to do the things you need will allow you now to know that and understand. It all depends on how you use it to execute your task of building a drone properly.
Right. And so all of this that we just went over, and tools determine that execution that we're working towards.
Correct. Exactly. And that's the biggest part, just building out a system that works well and giving you the tools as the viewer to know what you need to know from our experience from time, because this will help save you a lot of hours of research and time overall.
A lot of headaches. So I mean, if your tools are bad,
your systems will be too. With that, thank you and appreciate it. This ends our 7-part series for the SUAS, and we'll have another exciting episode coming up soon. And we think that the next episode everyone will enjoy it. It'll be something very interesting for you to get. So that being said, I'm Vincent Lewis.
I'm Josh Hill. Appreciate you guys.
Thank you. This is Swarm News. Catch y'all later.